Welcome back to another deep dive with my Mind MashUps. We take a whole stack of sources, pull out the key stuff, and, well, try to make sense of complex topics for you. Today, we're diving into something called vibe coding. Sounds a bit out there, right? But it actually points to a pretty fundamental shift in how software gets made. Okay, let's unpack this. Our mission is to explore what vibe coding really is, how people are actually doing it, the benefits, which are surprisingly big, but also the significant risks involved, and what does it all mean for the future of tech and jobs, of course. We've got expert analysis, tech reporting, even the original posts from people who started this whole thing. And hey, if you find this useful, please do give us a like, maybe share it, and definitely hit subscribe or follow my Mind MashUps. It helps us keep doing these deep dives. Thanks. All right, so vibe coding. The name itself feels kind of intuitive, like just going with the flow. But what does it actually mean?
Yeah, what's fascinating is just how fast this term caught on. It was coined by Andrej Karpathy, the AI researcher, back in early 2025. He put this post up on X, Twitter, as it was talking about his new way of working with AI. He kind of joked about it, saying, felt like building a project, but it's not really coding.
Not really coding? What do you mean by that?
Well, he described it as just like seeing stuff, saying stuff, running stuff, and copy-pasting. And his kicker was, and it mostly works.
Mostly works. Uh-huh. That sounds slightly terrifying for production software.
It does. But that phrase, that sort of ambiguity, really struck a chord. Almost overnight, vibe coding became the term for this AI-first development style. It spread so fast, Merriam-Webster actually added it by March 2025, for definition. Basically writing code by just telling an AI program what you want and letting it create the product for you. Often noting, the code might not be perfect.
Okay, so it's shifting away from needing to know the exact syntax, the commands, and more towards just describing what you want in plain language.
Exactly. And this plugs right into Karpathy's bigger idea of software 3.0. He talks about software 1.0, that's your traditional code, Python, C++, Wary, written line by line. Then software 2.0, that's neural networks, machine learning models trained on data. The model figures out the solution itself. And now, software 3.0, this is where large language models, LLMs, become kind of like programmable computers themselves. And the code you write, it's just natural language, English prompts, basically.
That's a huge change. Moving from technical code to just human language as the main way to build software. So how does this trust the AI thing actually work in practice when someone sits down to build an app this way? Well, yeah, the practical side really leans into this loose, almost trust fall with the AI. It's less about being a super precise engineer, maybe more like a creative director. The process usually starts with what you could call vision casting. You just describe what you want conversationally, like, hey, build me an app so users can track their mood each day with emojis and maybe see trends over time. Simple as that. Then phase 2 is the AI interpretation and construction. The LLM takes your description, figures out the tech stack, front-end, back-end database, and just starts writing the code, scaffolding it out, filling it in. It's incredibly fast. And then the last part is human refinement and iteration. This is where the developer steps back in, treats the AI's code like a starting point, a sandbox really, and get this, if there's an error, often you don't even dive into the code. You just copy the error message, paste it back to the AI, and say, hey, fix this.
That's a great summary. It really does change the developer's role. You're less of a hands-on coder hammering out syntax and more of an orchestrator. You're managing the AI, guiding it, almost like it's a junior developer on your team, albeit a very, very fast one. The key skill becomes less about perfect syntax and more about clear instructions, setting the right goals, guiding the AI effectively. Makes you wonder about the learning curve, right?
Oh, absolutely. And here's where it gets really interesting because we're seeing actual examples. Karpathy himself built this thing called MenuGem, an AI tool to generate pictures for restaurant menus. He built the entire web app end-to-end without writing code himself. He literally said 100% of the code was written by Cursor plus Claude AI, and I basically don't really know how MenuGem works in the conventional sense.
Yeah.
He just kept telling the AI what features to add, what bugs to fix. He said it felt like he was 80% done in no time. Sounds amazing.
It does, but there's a catch.
Right. He also found the AI made stuff up, like outdated API calls. Deployment was tricky. And as the app got bigger, he admitted that while the AI thought it was maybe 80% done, reality felt a bit closer to 20%. The code got so complex it went beyond comprehension for him to easily tweak.
And that gap, that difference between how complete it feels versus how production ready it actually is, that's really key. But still, the accessibility aspect is just undeniable. We've seen reports of like a product designer, zero coding background, building a working dog identification app in just 2 months with ChatGPT.
Wow.
And a mechanical engineer took an old iPad app, converted to a modern web app in 2 hours just by following AI instructions. Then built a complex database tool in a week. It genuinely lowers the barrier. Entrepreneurs, hobbyists, people without that computer science degree, they can now build things. It's democratizing software creation in a way maybe like nothing before.
And it's hitting the startup world hard too. Rapid prototyping is getting supercharged. In Y Combinator's Winter 2025 batch, something like a quarter of the startups had 95% of their code written by AI.
95%.
Yeah, think about that. MVPs, prototypes that used to take months, now potentially days. Solo founders can suddenly move like a whole team. It's wild.
And beyond startups, you're seeing tons of community experiments. Forums, hackathons are buzzing, people building little tools, games, websites. Simon Willison, a developer who tracks this stuff, documented building over 80 small projects this way. He called it a fun way to play with the limits. It really taps into a kind of playful creativity, especially for smaller, less critical projects.
Right, so there's clearly a lot of excitement. Speed, accessibility, creativity.
Yeah.
What are the main upsides people are really pointing to?
Well, number one, as we've touched on, is just raw speed and productivity. AI can generate code unbelievably fast. Karpathy said getting a UI built was an order of magnitude faster. We're seeing reports suggesting project completion times improve by up to 55%, maybe even 2-3 times the development speed. For getting prototypes out the door, that's huge.
And the accessibility and democratization piece feels massive. It's not just easier coding, it's potentially no coding needed for some things. The New York Times piece put it bluntly. You don't have to know how to code to vibe code. Think about a small business owner, you know? Someone with a great idea, but no tech skills, no budget for developers. Now they might actually be able to build it themselves. It feels like a step beyond even no-code tools.
Totally. And that flows into the next point, creativity and higher level focus. If you're not bogged down in semicolons and syntax errors, you can spend more brain power on the big picture. The design, the user experience, the actual problem you're solving. It keeps developers or creators kind of in that creative flow state, more like brainstorming with a partner than grinding out code. People might try bolder ideas because the initial effort is so much lower.
What about existing developers? Is it just a threat, or is there an upside for them too?
That's a good question. Proponents argue it actually drives skill acceleration. You have to get really good at specifying exactly what you want, and you learn to read and debug code the AI generates, which are important skills. Plus, developers are using it like a tutor. Want to try a new language or framework? Ask the AI to generate some examples. Some veterans even think it could help junior engineers get up to speed. Maybe become full stack, way faster than before.
Interesting.
And then, zooming out, there are potentially huge issue shimar reasons, new business and economic opportunities. An entire ecosystem of AI coding tools is booming. Startups are getting funded. Investors are calling it Silicon Valley's next act. There's even talk of an Uber effect for code. If making software gets radically cheaper and faster, maybe the demand for software just explodes, which could, paradoxically, lead to more programming work overall. Just different kinds of work, augmenting developers, not just replacing them.
Okay, that paints a pretty rosy picture. But surely this kind of speed, this reliance on AI, it must have downsides. What are the big red flags people are raising?
Oh, definitely. A major one is code quality and maintainability. If you just accept whatever the AI spits out, you often end up with black box code. Code that works, maybe, but nobody on the team fully understands how. This builds up technical debt like crazy. One CTO described it as surrendering code comprehension, basically, hoping the AI got it right. That's fragile for anything important or long-lasting. He mentioned having to rewrite AI code from scratch because he couldn't understand it well enough to optimize it. Mostly works, just isn't good enough for production systems.
Yeah, that makes sense. And if you don't understand the code, debugging must be a nightmare.
Exactly. Finding subtle bugs is hard enough in code you wrote yourself. In complex AI-generated logic, it's way harder. You can feed the error back to the AI, sure, but it might just patch the symptom, not the root cause. Even Karpathy admitted that as his MenuGem project grew, he lost that initial speed advantage because he had to spend so much time just reading and trying to understand the AI's code.
Okay, and then there's the really scary one, security vulnerabilities. I've seen some alarming numbers on this.
Yeah, the stats are pretty sobering. Studies suggest something like 40–45% of AI-generated code contains security flaws. Things like missing checks on user input, hard-coded passwords or keys, vulnerabilities to injection attacks. It's concerning.
40%, wow.
And it's not just the common stuff. Vibe coding can introduce new kinds of risks. There's dependency explosion. A simple request might pull in dozens of libraries, massively increasing the potential attack surface. And then there's hallucinated dependencies. The AI might suggest using a library that doesn't actually exist. An attacker could then register that name, upload malicious code, and boom, you've just installed malware by trusting the AI.
Oh.
Auditing is absolutely critical.
That's terrifying. What about the impact on developer skills long-term? The erosion of skills?
That's a huge debate. Lots of experienced programmers and educators worry that over-reliance will de-skill people. If new developers just learn to prompt and pray, will they ever learn the fundamentals? What happens when the AI gives you bad code or the problem gets really complex? Andrew Ng, the AI expert, warned that using these tools is still a deeply intellectual exercise. You can't just switch your brain off. There's a fear of creating developers who hit a ceiling because they lack core understanding.
Right. And finally, just the basic reliability of the AI itself.
Yeah, LLMs hallucinate. They make things up. Their knowledge is frozen at a certain point in time, so they might suggest outdated practices or libraries, like Karpathy found. Relying too heavily means you inherit the AI's limitations. Plus, there's that weird perception gap study. Developers felt 20% faster using AI tools, but on realistic tasks, they were actually 19% slower, probably due to debugging time. The initial easy win can hide downstream costs. For now, vibe coding seems best suited for maybe lower stakes projects where bugs aren't catastrophic.
So, given all this, the excitement and the serious concerns, how is the tech world actually processing this? What are the different reactions, and where might this be heading?
Well, among developers themselves, you see a real split. You've got the early adopters who are all in, loving the productivity boost. Some are saying they can't imagine coding without AI help now. But then you have many seasoned engineers who are deeply skeptical. They see it as potentially irresponsible, encouraging shortcuts, ignoring the craft of careful design, testing, and maintenance. They argue rightly that software engineering is way more than just banging out lines of code. So yeah, there's definitely a vibe coding divide opening up.
I can imagine. What about the bosses? The tech leaders, CEOs?
They're definitely paying attention, though often with cautious optimism. Sam Altman at OpenAI thinks engineering will look very different very soon. Mark Zuckerberg suggested AI might handle mid-level engineering tasks. Initially, some companies were hesitant, worried about intellectual property, security risks. But as more success stories emerge, that seems to be shifting. Now the focus is more on, okay, how do we train our people to use these tools responsibly?
And what about education? How are schools and boot camps handling this?
They're right in the thick of it. It's a huge discussion. Some are integrating AI tools directly, teaching prompt engineering, how to verify AI output, treating it like the calculator in math class. It's here, you have to learn to use it effectively. But there's also that worry. Are students just taking shortcuts? Are they missing out on learning the fundamentals if the AI does the heavy lifting? Pedagogy really needs to adapt, and quickly.
And for the wider public, the economy. This must feed into the whole AI taking jobs narrative.
It definitely does. That fear is real. But there's also that counter-argument, the Jevons paradox, or the Uber effect idea we mentioned. If AI makes creating software drastically cheaper and faster, maybe the total demand for software goes through the roof. We could end up needing more people involved in software creation overall, but their roles might look different.
So the human coder isn't necessarily obsolete, but their job changes.
That seems to be the consensus, yeah. Knowing how to effectively leverage AI, how to guide it, how to validate its output, that's becoming the crucial skill. The bottleneck shifts away from just typing code towards higher level thinking, ideation, design, strategy, domain expertise.
Okay, so looking out 5, maybe 10 years, what's the forecast? Where does vibe coding go from here?
Well, most predict AI will just become the new normal in coding. AI assistants will be built into everything, as standard as spell check or compilers are today. Future tools, IDEs, might let you literally just talk to your code base. The day-to-day work will shift more towards oversight, validation, high-level architecture, while the AI handles more of the routine implementation.
Which leads to a redefinition of developer roles, right?
Exactly. Maybe we'll see titles like software editor, AI software trainer, prompt engineer. Guiding the AI becomes paramount. But, and this is key, strong fundamentals in computer science and design thinking will likely become more important, not less, for making good architectural choices and knowing when the AI is wrong. You need that hybrid fluency.
Interesting.
We'll probably also see new software engineering paradigms, maybe things like VibeOps, like DevOps, but for managing AI-driven development cycles. And development could become multimodal, using voice commands, drawing interfaces, not just typing prompts.
And hopefully better quality and safety nets.
That's crucial. The tooling has to be better. We'll see improved AI models, dedicated AI debuggers like Cursor's BugBot concept, AI security scanners, AI code validators. The goal has to be making AI code more transparent, more reliable, more explainable, maybe eventually reliable enough even for critical systems.
And the job market. What's the final take there?
It's uncertain, but the dominant theory seems to be a shift, not necessarily a net loss. Perhaps fewer pure entry-level coding roles focused solely on implementation, but potentially many more roles for soup developers who leverage AI effectively. And if that Jevons paradox holds true, soaring demand for software could create entirely new industries and niche roles. The bottleneck moves up the stack from how to build to what to build and why.
Okay, so wrapping this up, vibe coding feels like this double-edged sword. Incredible potential for speed, accessibility, innovation.
Yeah, democratizing creation in exciting ways.
But balanced against really serious risks around code quality, security, maintainability, and maybe even de-skilling the workforce if we're not careful.
Exactly. It really comes down to finding that new balance, that new sort of contract between humans and AI in the creative process. Success means embracing that generation verification loop. Let the AI generate, but humans must verify. It requires cultivating what you might call hybrid fluency, being literate in AI tools and strong in core programming principles, and always focusing on the human strengths: strategy, creativity, ethics, understanding the real-world context.
So the craft of programming is definitely changing, maybe evolving into something we wouldn't even recognize today. Will it lead to a mess of buggy software, or will it unleash an unprecedented wave of innovation? That's maybe the big question to chew on. Thank you so much for joining us for this deep dive today. We really hope you found it insightful. If you did, please do us a favor, hit that like button and subscribe, or follow my Mind MashUps wherever you get your podcasts. We've got lots more deep dives coming. You can find us on Amazon Music, Audible, Facebook, Pocket Cast, Spotify, and YouTube. Thanks again, and until next time, keep exploring.